On this video, we're going to work some problems to practice for the Chapter 9 test. So here we have square root of 3 secant theta minus 2 equals 0. We just have one trig function, so we're going to try to get it by itself. So we'll start by adding the 2 to the other side, and then we'll divide by the square root of 3. Don't rationalize, because we can see that secant theta is the reciprocal of cosine. So we can take the reciprocal of both sides of the equal sign and get cosine theta is square root of 3 over 2. So hopefully we recognize that, and cosine is equal to square root of 3 over 2 in quadrant 1. It's going to be at pi over 6. So we're going to get theta is equal to pi over 6, and then we can say plus or minus 2 pi n. And cosine is also positive in quadrant 4, so we could call that a negative pi over 6 plus or minus 2 pi n, or we can write it very compactly as a plus or minus pi over 6 plus or minus 2 pi n. Okay, now we're going to change our domain to just 0 to 2 pi. We see that we have two different trig functions, which is not generally very good, but since the sine is squared, we know from our favorite trig identity, sine squared plus cosine squared is equal to 1, that sine squared is equal to 1 minus cosine squared. So we will replace the sine squared by 1 minus cosine squared x so that we can make this equation have only cosines. So we'll distribute, and that's going to become 2 minus 2 cosine squared x minus cosine x equal to 2. We're going to try to factor this ultimately. I like the squared term to be positive, so I'm going to move the cosine squared to 2 cosine squared x to the right side and add the cosine x there. When we subtract the 2's, they're going to drop out and we'll just get 0. Now don't divide by cosine x, because then we'll lose the chance for cosine to be equal to 0 and be a solution. Instead, factor it out as 2 cosine x plus 1. Now we have two things multiplying to be 0, so either cosine x is 0 or 2 cosine x plus 1 is equal to 0. If cosine is 0, then that's going to give us pi over 2 and 3 pi over 2 as solutions between 0 and 2 pi. If 2 cosine x plus 1 equals 0, then cosine x is negative 1/2. So that is going to add to our list of solutions. Now we know that cosine in quadrant 1 is going to be a pi over 3. Cosine is negative in quadrants 2 and 3, so that means we're going to get 2 pi over 3 and 4 pi over 3. So there are our solutions. Now this next one's a little tricky. There's a couple ways we can do it. I think the way I would lean towards is let's rewrite these as sines and cosines. When we do that, we can see that they both have denominators that are sine x. So if we multiply through by sine x, we'll get rid of those denominators. So that will become 1 minus cosine x, and then we'll get a sine x on the other side. So now we have two different trig functions in the same problem, like we did originally, but now we have nicer trig functions than the cosecant and cotangent, ones we're more familiar with. In order to trade them in, like we saw earlier, we need for something to be squared. So we're going to need to square both sides. Now when we do this, we need to remember that we're going to have to be wary of our solutions and check them in the original to make sure that they aren't extraneous. Now 1 minus cosine x quantity squared, we don't distribute. Remember, that's going to be the first one squared, twice the product, plus the second one squared. And on the other side, we're going to get sine squared x. Now we're back like that first problem over here, where we have two different trig functions. So as we did before, we're going to trade in that sine squared for a 1 minus cosine squared x. Now we're going to try to get everything on one side of the equal sign and 0 on the other. So adding that cosine squared x is going to get us to 2 cosine squared x. We still have that minus 2 cosine x, and the ones are going to subtract off. They're going to kill each other off, so we just have it equal to 0. Now I'm going to bring it up here and factor out a greatest common factor of 2 cosine x. That will leave behind a cosine x minus 1 equal to 0. So if 2 cosine x equals 0, then dividing by 2 gets us cosine x is 0. So x can be pi over 2 or 3 pi over 2. From the other factor, we're going to get cosine x minus 1 is 0. So cosine x is positive 1. That's going to add only 0 to the mix. Now we have to be skeptical because we squared both sides along the way, so we need to check these back in the original, which is really like plugging them in here. So if we put in pi over 2, that's going to get us 1 over sine of pi over 2 minus cosine of pi over 2 over sine of pi over 2, and we're seeing if that is in fact equal to 1. Well, sine of pi over 2 is 1, so that's going to be 1. Since cosine of pi over 2 is 0, that's going to be 0, and that really does work, so pi over 2 gets to be in our solution set. Now we can try 3 pi over 2, and we get 1 over sine 3 pi over 2, plus, or minus rather, cosine of 3 pi over 2 over sine of 3 pi over 2, still trying to make that equal to 1. But this time, the sine of 3 pi over 2 is a negative 1. Cosine 3 pi over 2 is still 0, and that is not going to work. So that means that 3 pi over 2 is extraneous. So now we try 0, and so we get 1 over sine of 0, but we can stop right here because sine of 0 is 0, and 1 divided by 0 is not defined, so that can't be a solution. So that means the only solution we get is pi over 2. I'm going to scroll up a little bit. So now we're going to solve for tangent of 2x, and we're going to subtract that square root of 3 to the other side. So now we want to know what angle is going to make tangent a negative square root of 3. So if you're good at this, you can see that square root of 3 over 1 comes from square root of 3 over 2 over a half. So sine theta and cosine theta, they're each going to be, the sine theta is going to be square root of 3 over 2 at pi over 3, and that's the same angle that makes cosine 1/2. So that's one way to get it. Alternatively, if that's hard, we can say the angle whose sine is square root of 3, using Pythagorean theorem, is, and here we can get again that using this triangle, that the cosine of theta is opposite over hypotenuse, or I'm sorry, adjacent over hypotenuse, and that's going to get us our reference angle of pi over 3. Now, tangent is negative in quadrants 2 and 4. So with a reference angle of pi over 3, that's going to be 2 pi over 3 and 5 pi over 3. But let's pause a moment. We started with our domain was going to be from 0 to 2 pi. That means that x must be between 0 and 2 pi. But this 2x means that if we multiply through by 2, that means 2x can go all the way to 4 pi. So let me back this up a little bit here. So that means we're looking for solutions. We said 2 pi over 3, and that was 2 pi over 3. That's a funny way to write 3. 2 pi over 3 and 5 pi over 3. That's one trip around the unit circle. So we can add another 2 pi to each of these. 2 pi is 6/3, so 8 pi over 3 and 11 pi over 3 will work for 2x. If we divide everything by 2, that's going to give us x is going to be, to divide by 2, we can cancel and get pi over 3. 5 pi over 6. Dividing by 2 makes 8/3, 4 pi over 3, and 11 pi over 6. Notice, just kind of as a check, our last answer is less than 2 pi. So our x's really are between 0 and 2 pi. Okay? Now we're going to solve over, and we've got some domains that are going to change from problem to problem. So we're going to start by getting sine x by itself. So that means sine x is -1 over square root of 2, which when you rationalize it is negative square root of 2 over 2. So sine is positive square root of 2 over 2 at pi over 4. That's our reference angle. Sine will be negative in quadrants 3 and 4. So if we go in our positive direction, that first angle is going to be 5 pi over 4, and the next one is going to be 7 pi over 4. Now we can also go in a negative direction. We still want to get to those same quadrant 3 and quadrant 4 angles. If we go in a negative direction, that'll be a negative pi over 4, and that will be a negative 3 pi over 4. And those are going to be our solutions between negative pi over 2 and positive pi over 2. So if we solve the secant one, we're going to subtract the square root of 2 to the other side. We recognize secant is 1 over the cosine. So if we take its reciprocal, that becomes a -1 over square root of 2, which when we rationalize it is negative square root of 2 over 2. Now we know that the reference angle, cosine, is a positive square root of 2 over 2 in quadrant 1 again at pi over 4. Cosine is going to be negative in quadrants 2 and 3. So our domain here is going to be from 0 to 4 pi. So the first angle we encounter is going to be 3 pi over 4. The next angle is going to be a 5 pi over 4. We're going to keep going till we get to 4 pi. So then if we go around the circle, 2 pi, another 3 pi over 4 means we're going to add 2 pi or 8/4 to the 3 pi over 4 to get 11 pi over 4. And continuing on, we're going to add 2 pi to the quadrant 3 angle. So 8/4 plus the 5/4 will be 13 pi over 4. And these are going to be our answers between 0 and 4 pi. Now we're going to go back to solving between 0 and 2 pi. Since we have everything's the same trig function, but we have a quadratic, we're going to try to factor that. So we might think of our box and diamond. So that's going to be a -2x squared, and we have a 1x for our middle term. And so we're looking for two things that multiply to be -2x squared and add to be a +1x. So I think that's going to be a +2x. and a negative 1x. Then we go to our box, and so we're going to have our negative 2x squared here, I'm sorry, positive 2x squared here. And we've got our negative 1 here, and we can put a positive 2x and a negative x in either of those diagonal squares. Looking for the greatest common factor, looks like a 2x here, multiplies by x to be 2x squared, and by 1 to be 2x. X times a negative 1 will be negative x, and our negative 1 times 1 matches that negative 1. So that's going to factor into our x plus 1, but our x is really sine x plus 1, and 2 sine x minus 1 are going to equal 0. So that means sine x is negative 1, or 2 sine x is 1, making sine x 1/2. So sine x is negative 1 at 3 pi over 2, and sine x is positive 1/2 in quadrant 1 at pi over 6, and in quadrant 2 at 5 pi over 6. So those will be our solutions. We didn't square both sides, so we don't have to worry about extraneous solutions. Now we've got 2 cosine 3x plus 1 equals 0. So we'll start by subtracting that 1 to the other side, and then we will divide by the 2. And so we want to know what angles are going to make cosine a negative 1/2. So cosine, the reference angle, cosine will be a positive 1/2 at pi over 3. Cosine is going to be negative in quadrant 2 and 3. So that is going to give us 2 pi over 3 is that first angle, 4 pi over 3 is the next. But we see we have this 3x, so remember that means x has to be between 0 and 2 pi, but when we multiply through by 3, that means our 3x is going to go all the way to 6 pi, or 3 trips around the circle. So here was our first trip around the circle. The second one, we're going to add 2 pi, or 6/3, to each of those, making that an 8 pi over 3 and 10 pi over 3. Then we can go around again, add another 6/3 to each of those, making that 14 pi over 3 and 16 pi over 3. Then we're going to divide all of those by 3, which is like multiplying by 1/3. So that will become 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. And we know that 18 over 9 would be 2 pi, so all of those are still between 0 and 2 pi. Okay, here's our next one. Now we're going to need, because we have this 2x, which isn't in agreement with those other angles, we're going to need to use our formula sheet and see that the sine of 2x is 2 sine x cosine x. So we're going to replace that first sine 2x by 2 sine x cosine x, still multiplying that sine x, still equal to that cosine x. So we'll clean up a little bit. That's going to be 2 sine squared x and times cosine x. We're going to subtract that cosine x to this side to make it equal to 0. Don't divide by cosine because we'll lose a solution there. We can factor that cosine out, leaving behind the 2 sine squared x minus 1. So cosine x can be 0, and our 2 sine squared x minus 1 can be 0. Now here we can get that cosine is 0 at pi over 2 and 3 pi over 2. Now we need to do a little more work, so I'm going to come up here, and we can add that 1 to the right side, divide by 2, take the square root of both sides, which means we want the positive and negative square root of 1/2. We can split that up and go square root of 1 over square root of 2, and rationalize that to get a positive or negative square root of 2 over 2. So sine is going to be a positive or a negative square root of 2 in each of the 4 quadrants. So we're going to add to our list a positive pi over 4 from quadrant 1, 3 pi over 4 from quadrant 2, 5 pi over 4 from quadrant 3, and 7 pi over 4 from quadrant 4. All of those are solutions between 0 and 2 pi. Okay, now this one is also going to require us to use our formula sheet. It's really tough when we have different angles and they're being subtracted rather than multiplying. So we're going to look on our formula sheet at the sum to product, because we want to make these be multiply to be equal to 0, not add to equal 0. So the sine minus sine is that second one. So we're going to say that that's going to be 2 cosine of, and we're going to add those angles, 2x plus 4x, and divide by 2, times a sine of, and we're going to subtract those, 2x minus 4x divided by 2, and that's now going to equal 0. We can divide that 0 out, and that's going to look now like cosine 6x divided by 2 is 3x, times the sine of 2x minus 4x is negative 2x, divided by 2 is a negative x. Now we can use our knowledge that sine is an odd function, so a sine of negative x is the negative of sine x. So we can pass that negative sign all the way out in front, and then we can actually just divide it since it's equal to 0. So after all of that, we're looking at cosine 3x equals, cosine 3x times sine x equals 0. So either cosine 3x is equal to 0 or the sine of x is equal to 0. So our low-hanging fruit is that sine is going to be equal to 0 at pi over 2 and 3 pi over 2. Remember, we're going from 0 to 2 pi. But because of this 3x, remember, we've got that this means that x can be between 0 and 2 pi, which when we multiply through by 3 means 3x can go all the way to 6 pi. So we're looking for what angles will make cosine equal to 0, but we're going to go around the circle 3 times. So the first time around, cosine is going to be 0 at pi over 2 and 3 pi over 2. The next time around, we're going to add 2 pi to that, so that's a 4 halves. So we'll get 5 pi over 2, and let's see, 4 halves plus 3 is 7 pi over 2. Then we'll add another 4 halves to those, making 9 pi over 2 and 11 pi over 2. All of those are going to get divided by 3. So we are going to add to those that we already have and get pi over 6. Let's see, when you divide by 3, that becomes pi over 2. We already counted that once. Then 5 pi over 6. And then 7 pi over 6, then that's going to be 3 pi over 2 and 11 pi over 6. So those we've already counted. So these are all of our solutions. Okay, let's scroll up here. Now we're going to be using our half angle formulas, or we know, let's set the stage. We know cosine theta is 12/13, and this is telling us that we're between 3 pi over 2 and between 3 pi over 2 and 2 pi. So that puts us down here in quadrant 4. So there's our theta, and the cosine is the adjacent, and the hypotenuse is 13, and our Pythagorean triple, or you can use Pythagorean theorem, that's going to be 5, and because we're in quadrant 4, that's going to be negative. Now the alpha, so that's our theta. Our alpha we see is between pi over 2 and pi, so that's going to put us, there's pi over 2 and there's pi. That's going to put us here into quadrant 2. The sine is 3/5, and from Pythagorean theorem and knowing we're in quadrant 2, that's going to make that be a negative 4/5. Now, to evaluate sine of 2 alpha, we need our formula sheet, and the double angle formulas say that that's going to be 2 sine alpha cosine alpha. So from our triangle, we know that the sine of alpha is 3/5, and the cosine of alpha is negative 4/5. So that's going to be 2 times 3 is 6, times negative 4 is a negative 24/25. That's our sine 2 alpha. Now, the cosine of alpha over 2, our formula says plus or minus, and then it's going to be, so it's a plus or minus the square root of 1 plus cosine of alpha over 2. Now we've got to determine whether it's a positive or a negative. The way we do that is we see that alpha is between pi over 2 and pi. So to create this alpha over 2, we're going to divide everything by 2. So that makes alpha over 2 is between pi over 4 and pi over 2. That is going to be part of quadrant 1. So that means that our cosine in quadrant 1 is going to be a positive. So we're choosing the positive one. Now we get 1 plus cosine of alpha, and we said that cosine of alpha is a negative 4/5. So that's going to be a positive square root of, that's 5/5 minus 4/5 all over 2. So 5/5 minus 4/5 is 1/5. To divide by 2 is to multiply by a half. So that's going to be the square root of 1/10. So that's going to be the square root of 1 over the square root of 10. And we'll have to rationalize that to get our final answer, which is a positive square root of 10 over 10. Now, I'm going to slide this over a little bit. So the cosine of theta minus alpha, we're going to think of as cosine of u minus v. And in our formula sheet, that says that cosine u minus v is cosine cosine plus sine sine. Cosine cosine plus sine sine. So we're going to get the cosine of theta times the cosine of alpha plus the sine of theta times the sine of alpha. I'm going to slide back over a little bit so we can see it. Cosine of theta is adjacent over the hypotenuse. Cosine of alpha is the adjacent over the hypotenuse for alpha. Sine of theta is opposite, which is going to be a negative 5 over 13. Sine of alpha is going to be a 3/5. So that looks like negative 48 over 65, and then that's going to be a minus 15 over 65. So negative 48 and a negative 15 is a negative 63/65. There we got it. Okay, now we're going to rewrite a product as a sum. So we're looking for the product to sum formula options. So product to sum for for a cosine times a sine, looks like that bottom one. So this 6 is just going to hang out. Our formula says that we're going to get 1/2 times, and that's going to be the sine of u plus v, and then minus the sine of u pi over 3 minus v 5 pi over 6. Okay, so these are going to cancel, so we have 3. Now we got to get a common denominator, so that's going to be 2 6 plus 5 6 is going to be a sine of 7 pi over 6. And then the 2 6 minus 5 6 is going to be a negative 3 6, which is going to be a negative pi over 2. Now we know these values, so that's going to be 3 times. Now 7 pi over 6 is going to be down here in quadrant 3. The reference angle is pi over 6. Sine of pi over 6 is 1/2. In quadrant 2, that's going to be a negative 1/2. Now a negative we can pass through and make that a plus. Now we just have the sine of pi over 2. And the sine of pi over 2, that's right up here, is going to be a 1. So negative 1/2 plus 1 is a positive 1/2. 3 times 1/2 is 3/2. Okay, let's see what we can do with, now we have a cosine plus a cosine. So we want to look for the sum to product formulas. Let's see what that's going to do for us. So cosine plus cosine looks like that third formula. It's going to be 2 cosine of u plus v divided by 2. So 75 plus 165 divided by 2 times a cosine of u minus v over 2. So 75 minus 165 over 2. So that's going to be 2 cosine. Let's see, 75 plus 165. The 5 is going to make that 80. 80 and 160 is 240. 240 divided by 2 is 120. 75 minus 65, so that's going to be a negative 90 degrees. Negative 90 divided by 2 is a negative 45 degrees. So we can do negative 45, or we can use the fact that cosine is an even function, so it will just kind of absorb that negative sign, and the cosine of a negative is the same as the cosine of a positive. So I'm going to go 2. Now cosine of 120 is going to be over here. The reference angle is going to be 60, and the cosine of 60 is going to be 1/2, and in quadrant 2, that's going to be a negative 1/2. The cosine of negative 45 is the same as the cosine of 45. That's a square root of 2 over 2. So that 2 will cancel with one of those, and then we'll just get a negative square root of 2 over 2. Crazy. Okay, we're down to the last one finally. We're going to write this as the sum of first powers. So we know that sine squared u is going to be 1 minus cosine of 2u all over 2. So our sine squared times another sine squared is going to be 1 minus cosine 2x over 2 times another 1 minus cosine 2x over 2. So that's going to be over 4, and we're going to square that out. So that's the first one squared, twice the product, plus the second one squared. But now we still have a square, so we're going to have to do it again. So I'm going to, instead of making all the over 4s, I'm going to factor out a 1/4. So that just leaves us with that minus 2 cosine 2x. Now we know that the cosine of u is 1 plus cosine 2u over 2. But our u is 2x. That makes our 2u 4x. So that's going to be 1 plus cosine 4x all over 2. All right, I'm going to factor a 1/2 out of everything. That's going to make that be a 1/8. When we factor a 1/2 out of something, it's dividing by a half, which is multiplying it by 2. So that's going to become a 2. That's going to become a 4 cosine 2x. And we took that 1/2 out, so now we have a 1 plus a cosine 4x. We're almost there. Now we can write that as the 1/8 times, we can combine the 2 and the 1, 3 minus 4 cosine 2x plus cosine 4x. Wow, that was an ordeal. All right, we're good to go.